Alright, physics. Y'all had a test to take, and admittedly, not the world's smoothest operation. I do apologize for that. I gave back at least a few points here, due to my general mishaps. Nothing on your end. This was also all multiple choice. I'll address, there are going to be some short answers, some pre-response questions on your midterm proper. But seeing as there were still some issues here, I'm glad I ironed out, or I'm going to iron out, right, any problems with the multiple choice now. I'm also going to silence my phone because, okay, so that shouldn't go off. The first problem that came up was actually with the first question there, and the stone on the end of a string and such. So people were able to see this picture, but they didn't see these, and that was a problem. And that was a problem on my end. So I thought that if I uploaded multiple pictures to the same question, that it would show you the little arrows like it usually shows you, and it did not. You had to click on the picture and then toggle between the choices and then X out of the picture to go back to the enter your response. So if it comes up again where I need to upload multiple pictures, when I am typing up the question, I will make sure to say, click on the picture to view all of, or, click on the image to view all of the attached images for this question, so that you have the full story. As it stood, because there were enough people that emailed about not having the full story, and in the interest of not, reopening it and making everybody look for that one question again, I just gave the point. That was, again, an error on my end, what I'm doing here, trying to just go over it. So number one, if you have this stone going, oh goodness gracious, going around, oh my goodness, my computer is failing me, going around this way, but moving in a circle, the acceleration should point in towards the center of the circle, and there's actually only one acceleration that does that, and that's here in choice D. Right. If an object is doing circular motion, going in centripetal motion, then the acceleration of that object always points in towards the center of the circle. Right. Question number 2. You have a ball dropped from the top of a cliff. Total energy and elapsed time. The total energy of the ball is going to stay the same. Conservation of energy. Moving right along. Oh goodness. Hello? There we go. Why are we moving so much, computer? Can we not do that? Thanks. Alright, so the diagram below has a 155 Newton box moving from point A to point B. So we're moving from here to here, which means we're traveling this distance. I had to find gravitational potential energy. Well, I know that this is true. I have the height. That's h. 155 newtons is the force of gravity on the box, which is m times g. So 155 is m times g. 1.8 is h, which means my answer is 279. Right. Be really, really careful with the information that they give you about an object. If they give you that something is in newtons, that's a force. So it's a mass times acceleration already. If they give you that something is in kilograms, that's a mass. It's only a mass. Right? Now, number 5 here is on screen already, so I'm going to address it. What happens to kinetic energy and total mechanical as you pull something, right? And this is the key here, that it's pulled. The fact that it's being pulled means that energy is being added to it. So it's going to seem like, when I answer this question, that conservation of energy is broken. However, because it's being pulled, right, whatever is pulling the object, whatever's pulling this block, is losing energy in order for the block to gain energy. All right? So if we're only looking at the block on its own, then the block on its own, the kinetic energy at a constant speed will remain the same. So these are bad. I have to choose either C or D. If we're also going up an incline, that means that mgh is going up. Kinetic energy stays the same. mgh, potential energy, is increasing, means the total mechanical energy also must be increasing. And again, this is because we're looking at just the block, not the block and whatever's pulling it. If you had both objects, right, whatever is pulling the block is going to lose energy because it's using some of its energy in order to pull the block up the incline. All right. Oop, that was the wrong button. There we go. All right. Okay, I don't really have to erase that. I can stop erasing stuff. Again, number 4, really similar to number 1. We are here. Which way is centripetal force? So centripetal force, centripetal acceleration will always point in towards the center. That's choice C. I need something in equilibrium. That means that all the forces add up to 0, or all the forces cancel out. It cannot be moving in a circular orbit because centripetal force is acting just like it would be in number 4. It's not going to be going down a frictionless incline because it's speeding up going down the hill. It's not something falling freely because the only force acting on is gravity. There's nothing else to cancel it out. It must be the constant velocity. So constant velocity means that acceleration equals 0. Means that the net force equals 0. And that is what equilibrium means. So look for constant velocity, ideally in a straight line. We'll come back to that later. Number 7 got some of you. Number 7 got some of you. Y'all saw 3.5 meters. Y'all saw 8.9 seconds. Y'all saw average speed. 3.5 divided by 8.9 equals 0.39, and you circled question A, but that is wrong. And the reason that's wrong is because right here, it's a circular path. It means that this student is traveling like this, and this distance is 3.5, but they're traveling the outside of the circle. They're not traveling from the center out to the end and back. So the top here, the distance traveled is not 3.5. It's the circumference of the circle, which is 2 times pi times 3.5. And when you do that, you get c, 2.5 meters per second. It's still distance divided by time. You just need to be careful of what distance you are traveling. All right. Number 9, I'm reasonably certain I've given you this question before. If you look, we have a 50-meter high building and a horizontal speed of 4 meters per second. How much time is required for the stone to reach the level ground below? Ignore friction. So I need to know how long does this take, which means that this doesn't matter. I can't use that because it's a horizontal speed, and I'm looking for vertical. So I need YF. I'll use X. We'll use distance. Or D. D for distance. Sorry, I get mixed up in my classes. Final distance is initial distance plus initial velocity times time plus 1/2 times acceleration times time squared. The final position is 0. The initial is 50. If you're doing delta, it would just be that the change is 50. The initial velocity in the y direction, because we're dealing with up and down, is 0. We're kicking this perfectly horizontally, which means that 0 of it is up and down. So 0 times t plus 1/2, 9.81 meters per second squared times t squared. This goes away. I end up solving for t. T is about 3.19 seconds. Be real careful. If you forget to take the square root, you'll end up with 10.2. So just use caution. Right. I'll answer this one because it's right here. No unbalanced forces means equilibrium. That's choice C. Constant velocity. All right. Couple more. So 12 is a very much a be careful. Number 12. Throw a ball up and then catch it. Vertically up is positive direction. I need the velocity and time. It's going up to start. So its velocity has to start positive, which means it can't be this and it can't be this because both those velocities start at 0. This doesn't start at 0. It starts going up. It starts going up. Eventually it stops, right? Halfway through it stops, and both of those are good. After it stops, the reason he's able to catch it, or the reason this student is able to catch it, is because it falls back down, which means it can't do this. That means it would go back up. So that's this part C means that it goes up, it stops for a bit, and then it goes up some more. And that's just not what happens when things fall. That's D. Right? This is the velocity time. This would be true, would be good for distance versus time. The parabola would be good for distance versus time because it goes up and it comes down. Right. 13. 13 was a little tricky. You had to recognize that these two objects basically move as one thing. So if you find the acceleration of block B, you're also finding the acceleration of block A because they're moving as one object. They have a combined mass of 3 kilograms, and because F equals ma, that leaves me with choice D. All right. Number 14, this was the other question that I threw out because I had 2 correct answers. I didn't have this answer. On the test, this also said shorter, and both those were correct. The displacement is just from start to end. The distance is from start and everything that got traveled. So they ran from home to first, overshot, and came back. So the distance traveled was all of that, including the there and back. The displacement is only from home to first. So it is 6 meters shorter. It was supposed to be choice B. Some people chose choice D because that was also correct, but I ended up giving that point. Number 15, you should be really sick of seeing questions like number 15. Pulling a 60 Newton sled with a force of 20 newtons. So the sled is going to pull back with 20 newtons of force. Oop, runner. There we go. All right. So here's why I said be careful with what you're given. This is a 50 kilogram mass. It's lifted a certain distance in a time. Power is work divided by time. It's also, this is real similar to the lab that we just did. M times G times H divided by time, because work is change in energy. And in this case, we're pulling it straight up. So I have the mass is 0.5, I have gravity is 9.81, I have the height is 1.5, and the time is 5 seconds. 0.5 is 0.1. 0.15 times 10 is 1.5, so that's choice. Be careful, if you thought, if you just did force times distance and you used 0.5 kilograms for your force, you would have gotten A, so just be careful. Number 17 is just F equals ma, but we don't have A, but we can do V over T. So I have 0.149 times velocity, 15, divided by time, 0.04, and I would get about 56 newtons, or choice D. And finally, we have the child on a slide. The last thing I'll say before I tell you about the short answers is just, if you're not sure on what to do with a question, try throwing conservation of energy at it. At the beginning, they're at rest at the top of the slide. So that means they have potential energy. At the end, they're moving, and they're on the ground level, means they have kinetic energy. Masses cancel. I'm looking for height. So 9.81 times the height equals 1/2 times 7 squared. Half of 50 is about 25. 25 divided by 10 is about 2.5. That's choice C. Right. Be careful without losing halves. Be careful about losing squareds. At some point, I'm sure that I've messed this up a dozen times. So I try not to mess it up when I do the videos, but sometimes it just happens. For the free response questions, because they have to be like fill in the blank style, I'm not going to ask you to show work. Against my better judgment, I'm not going to ask you to show work. I would just like you to answer the questions as shown. Give me just the answers. Right, so the free response questions are all just going to be give me answers. I will say that you do have to put units. The only units that might be weird to enter in are meters per second squared, which you can just type in as m/s2. You don't have to put that little caret, which is 6, right? It's the shift 6 on the keyboard. But that's fine, right? Numbers and units. If you're missing units, I am going to take off. That's about all I can take off for. But if you're missing units, I'll take off. So for the free response questions on your midterm, which is next week, make sure that you have those. I'll be doing a little more review next class or next video. It'll be out of that little green book or out of the Regents, A recent Regents. It will be some free response questions if we haven't done them already. Continue to study, continue to look over things. Please make sure to get the lab in. I don't recall okay, full disclosure. I made a mistake when I was entering in lab due dates between your class and the AP class. So I believe that the due date for your lab got pushed later than it was supposed to. I moved it up a little bit. I think I have it due on Thursday. It was supposed to be due Tuesday the 19th. I believe I put it in as Tuesday the 26th. That's a mistake again on my end. I'll split the difference. Let's call it the 23rd, which I think is Friday. So please get that lab in. The power lab, you'll have to compare with some other people. Check my CBA for any other missing assignments, but otherwise, email me with questions, and I will see you next class. Take care, kids.